I ask a question?
Yes.
Is the final cumulative or
Final.
just after midterm?
After midterm. So they will be the last class for lecture, and the Wednesday we are going to have the final demo. So today we are going to, I don't think we can cover the entire part of the chapter 21 for the concurrency control. I'd like to introduce what is a concurrency control and how we can keep such a concurrency and the relational database management system, which is based on the transaction management that we discussed last time. And as I emailed you, so we are going to have the final exam on December 11th, Wednesday, 10:45 a.m., 12:45 p.m. here. So it's 2 hours exam. I don't think we need the 2 hours entire, but anyway, so that's assigned the final exam schedule. We are going to do that 2 hours. For it's after the midterm exam. We are going to start from the database programming, which was not part of the midterm exam. So your midterm will start from the database programming. So that includes database programming and chapter 16 the disk data structure for the data file and the index file and also functional dependency and normalization and also the relational database design algorithm, which we didn't cover. Then the query processing and query optimization. The last week we talked about the transaction the management, and today we are going to cover the concurrency control, the technique. Okay, that will be part of the final exam. So format is the same as the midterm exam. We are going to have the 40% the multiple choice, each I think the 15 to 20 the questions. I don't decide yet, so I'm going to make the question after today's class. But there's a 15 to 20, and the other will be the open-ended question. So that includes the maybe the after the demonstration, I'm going to give the little bit more details what kind of question you can expect from the open-ended question. Okay, then the Wednesday, the team will present regarding to the project demo. So that includes each team will have around less than 10 minutes, including everything, because we have only 75 minutes. So I think the 10 minutes may be enough for the class. That includes a very short introduction of the project topic. So that includes 2 to 3 pages of PPT file, and most of the time you can use the less of time for your demonstration. So live demonstration is not recorded. So please be ready for your live demonstration, how you can access your database and any special menu application and so on. So in your 2 to 3 pages PPT file introduction part, please demonstrate, show what is the purpose of your project and what kind of functionality and specifically your system architecture. Okay, what the web, if we are using web application, what the web application, for example, and for the database, we are using AWS or the GCP, the MySQL database, and so on. If we are using the standalone system, what is the client module? For example, Java, for the connection, we are going to use the JDBC and so on. Okay. So please, and also when you demonstrate, please show together with the MySQL database. If you create your user, so whether the user is created on your MySQL database and so on. So it's a good idea to show available the application part as well as your SSH to the MySQL server. So, but you cannot show everything within the limited time. So please think about the scenario of your demonstration. Okay. And don't waste too much time to fix, okay? So please be ready before the demonstration starts. Be ready, and we can share the project with the other students. Yes.
Is there a HDMI plug up there?
oh yes, HDMI is available, and also we have the VGA, and also if you want for the application part, so you can, if you are using the web application for Yahoo, you can use this one. So it's totally up to you, but please check with the laptop. Sometimes it doesn't work. So mine is okay, but always is a problem. So please check before your demonstration. And also your demonstration should definitely part of the final grade of your project is the how part, then the GA also will grade yours. Okay, so any question regarding to the rest of the semester? Then your everything should be submitted before the final exam. If you have any missing part or any changes, so please contact the GA, then finalize before the final exam. So right after the final exam, I'm going to finalize your final grade. Then we'll email you. Then probably you will get. I will allocate 1 or 2 hours of the office hour after the final exam. That will be Thursday or Friday to check your final exam only. Okay, then I will report to your final grade because the registrar office asked to report to your final grade before the winter break starts. So I'm going to speed up for the final grade. So which means please be ready to complete everything before the final exam. Okay, and also if you are interested in after completing this class, so some of the students ask me what will be the next class. So I'm mostly teaching the data mining or the data related subject, including NoSQL database. That is not offered in the next semester, but it will be summer or the fall semester. Then also I'm going to offer the big data course, but not this. I offer this semester, so it's probably either. So I think because of the limitation, I cannot offer that at the same time. So it can be either the summer or the fall, depending on the decision of the department. So that the next semester, I'm going to offer the data mining class. So data mining does not require prerequisite of the the machine learning or others. So I think that if you already took this class, it will be fine to cover to complete the data mining class. I mostly focus on the data mining, the application part. So you will have the 2-3 the project during the semester using the data mining technique, including the machine learning and the AI. Okay. And also, if you are interested in the big data concentration, so I'm not sure whether you realize that. Department has 2 concentration. One is big data and data analytics. Another one is network security, something like that, but I do not know. But the big data course, if you complete also only for the master, MSCS or MSc, it's a master level concentration. If you complete this data mining, big data, and NoSQL database, on your transcript, there's MSCS. Concentrate on the big data and something like that, not changing the major. Okay, your major is the computer science or the computer engineering, but concentrate on your the big data. And also, I strongly suggest to you, recommend you to take the AWS or the GCP, the certificate. I'm working with Google also to get the certificate, the benefit, like the discount voucher or the material. So nowadays there is more and more the cloud-based computing environment. So you should be able to use cloud computing resource. Also, you should show your ability. So certificate is one of the way. Okay. So it's the easiest way for the hiring department to check your credential and your ability. So it's not very expensive, not like the CCNA for the network. So and also it's a high demand. It's a kind of trend. I don't think it lasted several years, but right now to find a job is much more beneficial. It cannot guarantee, but it's also a good idea to get the certificates. So if you are able to use AWS or GCP, I think the fundamental, the certificate is, I think that you guys can easily pass such a fundamental level. the certificate. Okay, so today as I planned, so we are going to cover the last part. So of the semester is the concurrency control. Any question before we start? Okay, so there are two main operations in the database. If you remember, one is okay, so there are two main operations. One is read and another one is the write. So we are going to, there are different granularity, like you can read the database, entire database, or you can write the entire database from such a database level to the one value level. Okay, it doesn't matter what the level of the granularity, but we are going to the read or write for the data. Okay, then so at that time you can write the X, Y, Z, and just one such a database, the granular database object. So it can be the value level to the entire database. So it doesn't matter whatever of the granularity. So we are going to use such a notation. So read data item X. At the time X can be the certain attribute value, it can be the entire table, it can be database. And the write on the database object 1, something like that. At that time, so last time that we talked about the transaction management, we are going to use the transaction forward. So to avoid the synchronization problem. So we are going to define the transaction. Transaction is a logical unit of the data structure that includes a number of such an operation. Okay, so this one, the main characteristic of this transaction is autonomy. So ACID, we talk about the characteristic of the database transaction. So A means it's atomistic, so all or nothing. Once database transaction is start and should be ended or aborted. Okay, so commit or rollback, and consistency and isolation and durability. So atomistic is one of the characteristics of the transaction. So we are going to represent each transaction as a number, like the transaction 1, transaction 2, transaction 3, like that. So for example, the R1, the X means the transaction 1 read data item X. So W2 is the transaction 2 write the data item on the data item Y, like that. So we are going to use the notation and to explain about the concurrency control. Concurrency control is different from the consistency. Consistency means in terms of a database, so database has the database state. Database state means it's kind of the status, okay, which means it's alive. So database is not the dead thing or the cold copy. Instead, it's keep changing. So certain the snapshot of the database include the database structure. It's a schema plus data item. Okay, your data instances. So that is the database state. So when you read or write, when you do the something operation on such a database state is changing from A to B, certain database state to the another database state. So if you can guarantee such a change of the database state, so we can say it's a consistent. So we are going to believe that such a change database. If database is not consistent, inconsistent, so even though you change the value of database, so certain people, certain user can see the different the state of the database. Okay, we cannot guarantee. So that is inconsistent. That is a consistent or the inconsistent. The concurrency means at the same, it's from user level. So from the user, the concurrently the access the database is a concurrency. So for example, when the database is not the concurrent, so for example, if he is going to lock the employee table, so we cannot access the employee table because it's locked. Okay, then it's not concurrent. So we need to have the only serialize the processing one by one by one. Okay, so that is the concurrency control. So we are going to preserve such a concurrency control. So we cannot avoid. Idea of such a concurrency is we cannot avoid such a lock. So we should use the lock. Okay, so to address the problem of the synchronization. So for example, we have the shared data, and the consumer is multiple, like the CPU1 and CPU2, process 1 and process 2. So this shared data is a race condition. So at certain time, to keep the consistency, so we need to and also the concurrency, so we need to lock such a data item. So that's what we learned in the synchronization problem on operating system. Okay, but different types of lock. So we can use sometimes a semaphore, we can use something other, but we need to use such a locking mechanism. The problem is to keep the concurrency. If the multiple user access such a lock data, or so in cases, think about the simple case in your life. So when you are using the bathroom, only one bathroom, toilet door. If somebody uses, you should wait. Or, what else? You need to kick out the user. Okay, then you can take it. So, or you can give up. So it's you need to wait, or you need to time. Okay, you need to decide something. So, but depending on how to, whether you are going to wait, or whether you are going to die, or whether you are going to kick out the current user, it's a different the policy. So today we are going to see the one of the such a algorithm is a two-phase locking. So two-phase locking is a simple and the most popular approach for the concurrency control. So two-phase locking means, as you can see, it's a two-phase. It's a lock phase and unlock phase. So it's a very similar as the operating system. Okay, in your operating system, so you have learned the different such the solution. So you can get the lock. You don't have to get the lock, all the lock for your data item in one transaction. So eventually get the lock, and if you use and release the lock. So depending on how the manage such a resource, so there are different. So we are going to see the using the two-phase locking. We are going to see the concurrency control today. So main problem comes from the conflict situation. So as you learned in your operating system class, the conflict happens when first you should have at least the two transactions. If you have only one transaction, there is no problem. Okay, you are the only owner, you are the only user, so you can use your room whatever you want. But if you have your roommate, there might be problem. So always the two or more transactions. Then shared resource. You should have the shared resource. If you separate directly you're the room. So this left hand side is mine, and the right hand side only your roommate. No problem. Nothing. If there's nothing to be shared, so there's no problem. But if you share anything like the one door, okay, if you have only one entrance door, so it will be conflict like that. Okay. Then another important thing when you think about the conflict situation is if you read the data, only read the data, there might be no problem. Okay, so you can read as many the time as possible. However, if you write the data, if you change it, then that causes the problem. So you should have at least one transaction should have the writing. So there are three conditions. If you think about the conflict, so one is a multiple transaction, and data item should be shared. In this case, there might be no problem because it's different research. But in case of the share, is the problem. Then at least one of them should be right. So this is the conflict situation. If there is no conflict, you don't have to worry about the concurrency. because we have such a conflict situation, we should take care of such a conflict. For example, R1 of X. So this is a complete Y. We have a shared resource. We have two transactions. We have the right. What about the last one? The R1 of X. W1 of X. We have a shared and the right, but it's not complete. Why? Only one transaction, transaction 1. Read the data item hash, and then you can write, because it's the same transaction. So that is a complete. So if you cannot find any the non-complete, so there might be no problem. You don't have to do anything. Just to keep doing. But in case you can find such a complete situation, we should do something. It's a very, very similar as what? Lock management. So as you learned in the operating system, it's a lock management. So we are going to use the two-phase locking to understand such a control. So two-phase locking means the first phase is getting the lock, okay? And after you use, release the lock. So that is the locking, the two-phase locking technique. Okay. So first, the database concurrency management, the transaction management should have such the lock and the unlock operation in the DBMS system. So to get the lock means, what is a lock? You are the only one to use that item. Okay? There are two types of lock. One is shared lock. Another one is exclusive lock. So shared lock is you can have as many lock as possible for the item. For example, what? Read. When you read the data, when you read, it's also lock. Okay, I'm going to read this one, right? Why do we need to consider such a read lock?
Did you want somebody to write?
Yeah, somebody may change it, okay? So if we do not consider the read lock, shared lock, if somebody change, how can I guarantee the reading? As we have seen the last time, okay? So inconsistent. So then the exclusive lock is, in other words, it's a write lock. How many? So maximum 1 or 0. And this one is as many as possible. So there are two types of lock. So we can consider this lock and unlock is the operation. So kind of the module in the relation the database system. What happened unlock? Release the resource. So basic mechanism of using the resource, computing resource in the operating system is get the resource and use and release. Okay? Any types of resource is the same thing. So for example, think about your programming level. Read and open the file. Okay? So when you access the file, the structure on the file system from your program, you need to open. So for example, the fopen is the C or C++ programming, and or the Java is you can instantiate the file stream like that. Then you can read the data or whatever you want. Then if you are done, always it is suggested to close, release, because this during that time maybe shared lock or write lock. Okay, you need to return all your resource to the operating system. Then the other can access the data. It's not only the file, many the resource in computing system use the same mechanism. Lock, unlock is the same idea. It's a logical kind of the data structure level, the resource, lock, and after you use, and the unlock. So operation. We are going to use this. Then this definitely lock and unlock operation are automatic, which means either
Happen all
yes
the way
or nothing. So in the middle something happen, it should be go back. Okay? It's automatic. Okay? So we already showed the shared lock and the exclusive lock and the complete. certain situation. Then database provide the log manager. Log manager is kind of a module. So like the query optimization, query processing. If you, I'm not sure that I explained the detail. So it's a diagram for the DBMS. When you design, if you were developing the relational database management system, there are many components: query optimization, query processing, and interpreter, and so on. One of them is a log manager. Okay, so you are going to create a log manager. So log manager actually maintain just like the many other database components. So keep all the information about the transaction as a table. So which is called the log table. So we are the log manager. DBMS manages such a log table. This is really simplified. The log manager, like definitely it's a transaction by transaction. So we are going to keep the transaction ID and any data item that the transaction access and what kind of log, read log or write log, shared log or exclusive log, and the pointer to the next data item. Because this one transaction may have the multiple resources. So what is the next? The data item. So this is a log table. So in other words, if you are going to develop or design your own relational database management system, actually this log manager is not only a relational database, any type of the DBMS, NoSQL database. If you allow the multiple transaction, definitely you need to create the program to manage the log. At that time, you can create the log manager as a table format. Okay. So this is a pseudocode how you can create the how you can design and create the log manager, including such operation log item. So when you log, so we can increase. If nobody use that item, we can increase by 1, which means it's a log. Okay. So otherwise, you can wait. You can wait until the log is 0. So you can keep check. So whether this one is the available one. You have seen the same thing in your operating system class. So log, how can you check? Same as using the toilet bowl. So you can keep knocking. So every second, knock. Then if available, you can use it. So similar idea. So this is a pseudocode of the log, the database object. On log, you can release, and you can release that. Actually, the operating system class to manage the log, there is critical section problem. So you can define the group of code as a critical section. So critical section is the same idea as if you are using the textbook or any other, it's okay, it's not critical. But when you are using the toilet bowl, it's a critical section. So we are going to go next. Okay? So there are 3 requirements of the critical section problem. Like those who want to access the critical section vote for the next one, and that should not be infinite. So eventually you need to access such a thing. So similarly, the database log manager manage the log, search the log and unlock using the log and unlock operation. So this is simple, but there might be different ways to implement such a wake up, because spin lock is one of the problem. So which means if you keep knocking the toilet bowl, it will be crazy. The person inside, it will be crazy, and your entire system will be busy. So might be you can implement a different way. This is the easiest way to wake up. But for example, if the system monitor the log, the number of log, then the notify, something like that. But keep in mind, lock and unlock is the operation in the main. There are different types of log. So read log, you should manage first the write log. Write log is simple, either lock or unlock. Okay. If unlock, you can. If lock, you can wait. Okay. Then if unlock, you can release. You can update the lock manager. Then somebody can use that. However, the read lock, you need to increase the number of shared lock, increase by 1. Okay. If unlock, you can reduce the number. And if 0, then notify. So this is unlock the operation. Then sometimes because one transaction as a begin transaction and end transaction. In between the read data item X and the write data item X. That may happen. So at this time, instead of release the lock and getting the new lock for the same item, you can actually escalate the promote the lock from read lock to the write lock. So that is called the lock conversion. So lock conversion, there are two types. One is a lock upgrade or promotion, or the lock downgrade is the depromote. So upgrade is from read lock to write lock, and the downgrade is write lock to the read lock. Because if you unlock and getting the new lock is more complicated and using more resources. So to avoid the use, to simplify, we can upgrade the lock and downgrade the lock. So we have the lock, unlock, upgrade, and downgrade. And then, so using such an operation, we can implement the two-phase locking. So one is the first phase is a locking phase, and the second phase is unlocking phase. Then the problem is, I'm going to speed up. The problem is, there might be no problem to define the transaction and to use the shared resource. We can get the lock and as many lock as possible. Then use the resource and release the lock. Problem is when you have conflict. So the problem, main part is how to address such a conflict situation. So to do that, there are different approaches in two-phase locking. So one is the basic, the conservative first. Conservative means conservative. So it's a defensive, which means if I access the resource X, Y, Z, so first I want to make sure I am able to access all of these items that will be used in the transaction, entire transaction. So get the lock of X, get the lock of Y, get the lock of Z. If you get all the lock, then you can start. So it's a conservative. So it will not be a problem. The problem is once you get the lock, it will not be a problem. But the problem, you need to wait until get all the lock. So which will not be used in the practical situation. But this is a conservative. Okay. Then the basic is you can get the lock incrementally, which means so this is a transaction. You need the X here, you need the Y here, you need the Z here. Okay. So the conservative beginning transaction, you need to get all the lock that are required entire transaction. Okay. If you do not get the lock of Z, you cannot start your transaction. That is conservative. Basic is you can start whenever you need. You request the lock and you're getting the lock. And if you get, then move to the next and next. It's a basic. The problem is also you will stop if one is the lock by the other transaction. So you need to wait. So to deal with the such a thing, the strict version of a basic algorithm. So for example, the Z, so we are okay the X and Y, but the Z is locked by transaction 2. Is right, the Z. Then do I need to wait? So that is basic and the conservative. Instead, they race. So fighting each other. then winner take the item. So this one is started first. That doesn't mean so all the process can take the resource. No. So some depending on certain rule, we need to decide the winner. So there are two types of the solution to decide the winner. So one is called weight die. So weight die algorithm. So this one, the G transaction 2 takes the Z resource. Okay, then transaction 1 is asking the Z. At that time, check which one is older. Okay, older can take the resource. Wait, or otherwise just wait. If this one is younger than the die, so we terminate this transaction. If this one is older, like the transaction, maybe transaction 1 start this time and transaction 2 start this. Okay, then the transaction 2 can take the C. That may be possible, right? Even though it's a start late, so you can take. So then at this time, if they are racing, then the C, which one is older process? Then if this one is older, it can wait. Okay. Otherwise, if this one is younger, then we are going to kill. Then the rollback and start again. Otherwise, it can be, so which means overall, multiple transaction, we are going to make the transaction that start earlier can take the resource eventually. Okay. Otherwise, if we do not, so everything will be try to take the resource. So this is the weight die algorithm. Vice versa, Undo weight is the younger one will be the terminated, and either way is fine. So we are going to see the weight die algorithm today. I'm going to skip this part. This is entirely the operating system part. So regarding to the data log. Okay. So there are several solutions as you learned in your operating system class. So if you do not remember, why don't you record the deadlock management in the part of process management in operating system class. Okay, so we are going to use the weight die algorithm. So weight die algorithm, TS indicates the timestamp. So timestamp doesn't have to be the real word clock time. Most of the relational database management system uses sequence number. So if you start the database, okay, then it's every second, every millisecond, it will be increased. So monotonic increase. Okay, so 1, 2, 3, 4, 5, 6. So timestamp for if, for example, tx like this is a timeline. So 0, so start the database and the going on. So first time is a 0. So transaction start 1, start this time. It's the timestamp 10. Transaction 2 start the 20. So TS timestamp of the transaction 1 is less than TS transaction 2. Which means this one is older. This one is younger. Okay? So don't be confused. The last number means older process. The higher number, because it's a sequence number, means it's the younger process. So in case if you do not have any conflict situation, don't worry. You don't have to do this one. But since we have the complex situation, so if the timestamp, the TI is the transaction that caused the conflict. Okay? So in this case, the TI caused the conflict situation. Then, if TI is older, which means started earlier, but I'm requesting the resource because I started earlier, I deserve to get the eventually get the lock. So you do not kill the other process, but this one will wait. The reason why we wait this one is, if you remember the operating system class again, when you access a critical section, one should be selected to enter critical section. But this selection will not be infinite. So we are going to order such a process based on what? Timestamp. Reverse, a chronicle, or the other. So wait die is the chronicle. So older one will eventually take the resource. Otherwise, if this one is younger, which means transaction 1 start at 30, then this one hold the log overseas, but this one request. No, you do not have the chance, even do not have the chance to request this one. If we allow this to wait, it's everybody wait. Okay, there's no order. So in this case, it will be terminated. So that is the reason it's called the wait die algorithm. Then what happened? This terminated process. Start again the transaction. Okay, then later we'll get the chance of that. So this is a wait die algorithm. If you it's a vice versa. If you allow the younger process to wait, then it won't wait. It's the same idea to make the kind of sequence of the process. Always, such a deadlock management has the starvation problem. Okay? Starvation means it's a priority base. Okay? So one of the way to avoid to manage such a lock is the priority. You can give the priority of the process. So priority 0, priority 1, priority 2, priority. The Windows use 32 different levels of the priority. Then what happens? You have the lowest priority. You never get the chances if higher the priority, the process access the resource. So that is called the starvation. So you can address the starvation like for example, the promotion. You can escalate the high. If certain process wait 1 minute, and the next, the highest level, and next, eventually we get the resource like that. So this wait die or the wound wait may have such a starvation problem. For example, if younger, start again, it will be terminated. So we are going to the lock manager also add to the algorithm to avoid the starvation, like if we try the several times, escalate. Okay, there are priorities. There are different ways of the managing such a concurrency, but the way that two-phase locking is one of the most popular one. So to explain the real situation, I'm going to use actually I stopped to use the iCloud, the storage. Then at the time it's synchronized, which means delete all my latest, which is not the backup to the iCloud, will be deleted. So a lot of the lecture note that I modified the beginning of semester is gone. So because of that, I have sometimes only the PDF file. I didn't read the warning. When I stopped the iCloud, the synchronization, the account is synchronized. So I stopped, then this deleted, which was not synchronized. Okay, so let's see the two-phase locking. We have seen this one. There's another table the lock manager manage. One is the log table that we have seen. Another one is a transaction table. Transaction table is the general transaction management that include the ID and timestamp, because we should know when the transaction start. And as we have seen the transaction last class, so it has a different state like the active, which was the beginning transaction, and either aborted or committed at the end of transaction. So also blocked is the blocked by the killed by the other process and like that. So that is another table. So we basically have the two table, log table and transaction table. We have seen the pseudocode for this one. So and let's see the example. This is the last part of the semester, but not easy to understand the first time. So these are the operations that we are going to happen in the database. Let's see, the number means transaction. So you can see number 1, number 3, number 2, which means how many transactions. So eventually 3 transactions. And you can see the R indicate read, and the W indicate write. And also you can see the B, begin. It's a begin transaction. And you can see the E, end. So I think that you can easily guess. And also you can see the Y, Z, X like that. It's a database object. It can be table, it can be value, it can be the record. It doesn't matter. Okay. Then, so this is the example, a sequence of the database operation. It's a starting to end. It's a kind of timeline from top to bottom. So which means first B1, transaction 1 start, begin. And transaction 1 read data item Y. And transaction 1 write data item Y. Transaction 1 read data item Z. At that time, right after this one, transaction 3 started. Okay, transaction 3 start, and then the transaction 3 read data item 1 and so on. Okay, so then, as we have seen, the log manager of the DBMS manage the two tables. One is a log table that includes the full item, what is the log state, and what transaction is holding that item, and which transaction is waiting. Okay, and at the same time, the log manager use the transaction table that we discussed last time that include the transaction ID and state. So timestamp and state. So whether commit, block, and aborted, begin, like that. And any item, the database object that is used by the transaction. So we are going to make the two tables. So we will see the step by step. This is the before start the transaction, no transaction in the database system. Okay? Then first begin transaction. So we are going to assign the sequence number. So don't be confused. The transaction ID is different from the timestamp. Okay? That is the reason I intentionally order transaction 1, 3, 2 like that. Okay? So we are going to update the transaction table. ID is 1, timestamp is 1. Lower is older. So first transaction. And the currently is a start. So it's active. Okay? No problem. In other words, if you develop the DBMS, you can actually create the algorithm for the two-phase locking in your program using what? Lock operation, unlock operation, and read and write and such a thing, function that we have seen. Then update is the transaction and lock table. The next, no problem, the first operation. And transaction 1, read data item 1. So read log. So it's a read means first you need to get the read log. So update the log table. For what? Data item 1. what is the date, the lock type? Read lock. And which transaction? Transaction number 1. And this transaction table should be updated because it's still getting the read lock data item 1. So this is a current status when you are done the second operation. Next. So transaction 1, write the data item 1. It's the same item. We don't have to release and getting the new lock, instead upgrade. Okay, because it's the same ID, same transaction, and same item. So it's a transaction 1, the write lock on data object 1. Okay, it's an upgrade. So let's change the lock table. 1 is a write lock. It was a read lock, but this time it's a write lock. And this one still data item 1. So this is a current one. No problem so far. Then transaction 1 also read data items in. Yes, you can do that. So there's no conflict so far because it's the same transaction. So we can add the lock table. See, it's a read lock, transaction ID 1. Also, we need to add the item on the transaction table. So far, no problem, no conflict, no issue. Then, begin transaction. Transaction 3, start. Which means it has a timestamp 2. Okay? And update the transaction table, ID 3, timestamp 2. This is more important. Okay? Then there is active and no data item yet. So far no problem. Next, transaction 3, read on Y. So transaction 3 try to read the data item 1. Then check the lock table. Why? There is a 1. So check the TID is 1. Okay? So data item 1, transaction 1, and transaction 2, and what kind of lock? The transaction 1 is a write lock. Okay? And this one is a read. What is this? Conflict. It's a race condition. So we need to check whether wait or terminate. So how can we check? Using timestamp. So which one, whether, who caused that problem? Transaction 3 caused the conflict situation. This one, timestamp is higher. Higher means younger. Younger means die, terminate. Because we decide, if you have the wound wait, then wait. But we are going to use the wait time. So younger process, the first transaction that caused the conflict situation is younger, then we are going to terminate. So this time, we are going to abort the transaction 3. So update the transaction table. It's aborted. So no more transaction, the transaction 3 in the database. And this lock table is still exists. We give the permission, the transaction 1 to use this one. What happened? Transaction 3 is already terminated. So no more operation. It should start again, but there's no restart here. So then transaction 3 still you don't have to do it anything. It's just over. And transaction 1. Write on Z. Z was a read lock. Instead, write lock. We can upgrade. Okay. Then update the write lock. And transaction 1 is a YZ. So no problem. Then end transaction 1. And the transaction 1 means committed. It's just successfully the end of transaction. So we can commit. So transaction 1 is done. What happened lock table? Clear, because it returned all the results. Then when we start a new transaction like the transaction 2, we can start active and read the lock. No problem, because no the item on the lock table. Then continue. So lock upgrade, no problem. What happened? The transaction 3. It's already aborted. You don't have to. Unless it's restarted, you don't have to worry about that. It's aborted. Okay? E3 aborted. And R2 you can redraw on data item C and upgrade and the coming. So there might be no problem. How we address the problem using the wait diagram algorithm. In case the transaction that caused the complex situation is younger, we'll terminate. Otherwise, if this one, transaction 3, is started earlier, then we can let this transaction wait until the other transaction release the item. Okay? So that is the two-phase locking. This one still may have the starvation issue. Okay, it's not perfect. So this one may. For example, if transaction 2 restart every time, but unless this transaction 1 release the lock, so keep dying. Okay, keep the terminating. Okay. So at the time, to avoid such a starvation, we can upgrade or give the priority like that. But we don't consider here. So this is I try to show this one to give you the idea how DBMS system manage the lock. This is kind of example application of lock management on operating system. Okay, operating system you learn the many different ways of managing the lock, deadlock, and so on. This is one of the way, and also very critical in the DBMS system. Yes.
Yeah, when the first transaction is completed, when we aborted the third transaction, so why can't we again restart?
Oh yes, you can, but I didn't show the restart. So you can restart, but at the time, if you restart, you better have the starvation solution. In this example, I didn't show to simplify to understand how DBMS manage the lock and how to address. Yes, the two-phase locking is the simplest way. Actually, practically, they don't use. The commercial DBMS do not use. But basic idea is such a thing for your better understand. Then, actually, the DBMS use multi-version control. So this is the general idea of the lock management in the commercial DBMS, relational DBMS system. The reader never block the writer, and writer never block the read, which means if you want to write the data which is held by another one, you can still keep lock. Okay, keep using. How? We are going to allow multi-version, the buffer. So same A, if one is locked and a prime, a double prime, a triple prime, and multiple version, then we are going to what? Serialize the such operation. We didn't discuss detail the last time. Using the serialization, the schedule, we can schedule the operation by operation level. Okay, but they still keep changing the data. Otherwise, it will be huge waiting in a queue, so to wait. Okay, so that is just a rough idea. And this, the concurrency control will give you the how. The main part is this slide, how the DBMS and the lock kind of is an application of lock manager of the operating system. It's if you, especially our textbook, the our textbook, operating system textbook that we are, anyone who are taking the operating system? Yes, it's a textbook is the UBU's, the dinosaur. Do you remember? It's a dinosaur cover. It's a very well-known, most popular operating system textbook. I have used when I was student. It's a edition, 4th edition. I used right now. It's 10th edition like that. I forgot the name of the author. He is the professor in Yale University. He also authored the database textbook. So a lot of it's the common part, especially the transaction management, the lock management, and the data structure, the file structure is common between the operating system and database. That's true. As we talked a lot, database is application level, but it's not just the application. It's in between the system and the application. Okay, that's the end of the lecture so far. somebody the criticize, do we need to know about the operating system? Do we need to learn or teach the database? And because right now the programming part, especially the programming, is the higher abstraction level, which means you don't have to worry about the behind. So like the cloud, one of the reasons is the cloud service. So using the cloud, first you don't have to worry about the system, hardware, and the infrastructure. So also you don't have to hire the person if you are using the cloud service. The Amazon or Google will be in charge of such a thing. However, so you are not going to be just the programming developer or software engineer. Okay, so serverless the programming does not mean that you are not going to use the server. Instead, you are not going to worry about, you are not going to manage the server when you are doing programming. Somebody should manage such a server, somebody should design, somebody should. Like nowadays, the Amazon. It is true. In the Seattle, I met one of my friends in the city of Seattle College, where he's a professor in computer science. He said that there's a rumor around the Seattle that when Amazon is going to buy the Oracle, because Amazon is the biggest customer right now from the Oracle, because more and more the cloud service. That doesn't mean that we are not going to use the database system. That doesn't mean that we are not going to use the operating system. Definitely, the application program will be running on the operating system and certain operating system, and also the database will be used for the backend to manage the data. But it is true. Even though still the relational database is the biggest market share, the DBMS, but it's a little bit less and less. And more and more NoSQL database. But still, we need a database management system. So, do not set aside or ignore the importance of such a database and the operating system. I don't think that you are going to be just the programmer. So, it is true, the big company in Oracle or the Google or Amazon, they try to lower down the cost of developing, which means they try to hire such a software engineer and developer from the high school graduation level, the degree. Then they try to educate efficiently. Then because it is true right now, even with the master, a lot the developer with the master degree or master level. The master level degree in United States is not common. Okay. However, since the IT and the computer science is still the young and very high intensive education, it's a higher degree like the master, the degree. They are working for the developer, but eventually it will be lower down, like the college and even high school graduation level, which means you are going to not only it's like the designing the cloud infrastructure, or you are going to work for the management of the cloud service and so on. So please focus on such a part. So not only just the developer, but also you can do to do that. Until we have the quantum computing in the market. So it's the binary-based data structure and the operating system and the database and network also. So these are still I believe the core part of the computer science area. Okay. So but definitely you should know the program language and the algorithm part, but the plus in addition to that. So keep working for the database and the operating system and network and also security. That will be really helpful for future. So Python is just who knows, it will last only several years. We have the new programming environment like the serverless programming, but the server side will not be changed. If you have such a strong knowledge and experience, no matter what types of the programming interface or programming the strategy program language, I think that you can be survived. Any questions? Okay, so we will see on Wednesday. So each team will have the maximum 10 minutes to demonstrate, then we can finalize the semester. Then I will give a little bit hint to prepare for your final on Wednesday. Okay, thank you, and see you on Wednesday.